Hey, welcome to a very special edition of Show and Tell. This is the Hack Club Show and Tell. I'm John Park, and we are really excited today to have a group of makers who come to us from all corners of the world, who have been participating in the Summer of Making with Hack Club. And if you're interested, you can go and Google that, look up Hack Club. But what they had was a series of hardware grants that were made available to makers, high school-aged makers who wanted to build something. And so they reached out to us and said that they'd love to come on and show their projects. So we're going to meet some makers and see what they have created. So first up, I'm going to bring on Jack. Hey, Jack, how are you doing?
Good. How are you?
Very well, thank you. So tell me about a little about yourself and about your project.
So my name is Jack, and I am from Massachusetts. Uh, I designed a exoskeleton or a semi exoskeleton suit, and I heard about the grant, so I decided to give it a whirl, and I got the grant. So that's probably the only thing that's actually allowed me to do the project.
That sounds intense. An exoskeleton suit. Yeah, it probably can't be cheap either.
Yeah. Um, so I got all the parts around 2 weeks ago, so I started building it then. I got 2 legs done, and the electronics of component of it is not going so well. But I talked to a systems engineer at iRobot, and he's helping me out with that.
Oh, that's great.
Yeah, I actually have a picture of it. If share screen. Is this good?
Yeah, that's it. Just flip to that tab and you should be good. Yep.
So here's the original design for it. I got rid of a bunch of stuff from it because it really just wasn't feasible. But this is what I have so far. On the right is the 2 legs, and on the left is all the other components. This is what I have so far. It's really basics as of right now. And the engineer that I was talking about, he told me to build um, a bench power supply from a old PSU that I had on a previous PC build.
Excellent.
And that's kind of where I'm at right now.
Oh, that's great. And so you have visions of this being an assistive suit that you would wear and it would add to your strength?
Yeah, it's definitely not supposed to take over anything. It's just if you have slight arthritis or ankles not doing so well, you just strap it on and hopefully eventually it will be more assistive.
That is really exciting. A really cool project. Thanks so much for coming on and showing to us. It was really nice to meet you, Jack. And we hope to hear more from you in the future. If you ever want to come on Show and Tell again and show us your progress, we'd love to see it.
Yeah, definitely. I look forward to it.
Bye-bye.
Bye.
Oh, that's very cool. Okay, so next up, I know we got to keep this moving. We've got Kevin. Let me bring on Kevin. Hey, Kevin.
Yep. Hello, everyone. Yeah, I'm good.
So can you tell us a little about your project?
Yeah, if you could share the my screen. Yep.
Sure.
Yeah. So I made a little presentation for this, but it's quite short. It's just to keep my thoughts in line with what I wanted to say. But yeah, so this summer I made the Orpheus Leap, which you might have heard about. For those who are in Hack Club, you might have heard about it from the announcements page. And so this board will be distributed to people around the world, high schoolers around the world, for free from the Summer of Making grants granted by GitHub. Yeah, so just like a quick intro about myself. So I'm Kevin. I'm currently in Boston, Massachusetts, in that area. And so I'm an electrical engineer, a machine learning enthusiast, a PC designer, and an avid hackathon attendee. And so right now I'm working with a few UC Berkeley students on their combat robotics team, which is planning on competing in the 2021 season of BattleBots. So pretty cool stuff.
Awesome.
There. So just to give a quick background about the Orpheus Leap. So in the middle here is Roshan, and then on the right is Sam. They're both the leads for Summer Making. So Summer Making is the brainchild of them. And so Roshan approached me midway through Summer of Making saying, oh, hey, I have this idea I want to basically make a Arduino-based board in the shape of Hack Club's mascot, which is Orpheus, the dinosaur. And so, to me, this is a really cool idea. Like the instant he texted me that, I already had like a bunch of ideas for what I could do. And then I guess we just went from there. And then Hugo on the left here joined after I designed the board. Right now, he's designing basically PCB stickers, which we'll send an announcement later on once they're done in the Hack Club Slack. So here is the actual Leap itself. And so to give a few technical specs about it, the board is based off of the Pro Micro. So the Arduino Pro Micro, meaning it's running the Atmega 32U4. On it, there are 20 I/O pins, 7 of which are PWM channels, and 12 of which are analog inputs. And then something I want to just point out about the actual the part placements on the board. I've designed it in such a way that the actual components on the Leap follow the natural curvature of the dinosaur, which I think is quite neat. It took a while to get it to its current state because mostly it was tweaking here and there, and then eyeballing whether or not the distance between each component is good. Really well one other thing, I guess, is the tail and the eyebrows light up blue, which so when you plug in the USB, they will light up blue, which I think is quite neat. And then I've included a status LED and debug LEDs for the TX and RX lines.
That's really excellent. And so people are going to get their hands on this board sometime soon, members of Hack Club?
Yeah. Right now, it's currently being manufactured in China. It should be done by mid-October. So people in Hack Club will probably get it late October or early November.
That's excellent.
Do I have enough time to talk about my workflow or now?
You know what I'd love is, would you come back again next week on Show and Tell and show us more about your workflow? Because we got to keep moving so we can get to everyone. Yep. But I would love to hear it. I'm sure other people would too. Thank you, Kevin. Really great work. Bye-bye. All right. Let's see. Next up, we're going to bring on Julia. So get ready, because, hey, there's Julia.
Hello, I'm Julia. I'm from the Hack Club out in Ohio. And with my Summer of Making Hardware grant, I built this robot. It is a Land Rover that is based using a Raspberry Pi, a motor driver, and a lot of different servos with a breadboard. It's mainly it's coded in Python, and then the face detection through the Raspberry Pi is in OpenVC. And then the shell of it is built just out of wood. I did it myself. And right now, I would say the hardest part about it is just getting the facial recognition to turn both servos to be able to detect. But so far, I would say the process is going pretty well.
That's excellent. So you're using, did you say you're using OpenCV to recognize faces? Yeah. And is that something you need to train with faces so that it learns the faces it's looking for, or is it general?
Yes, so if you go on GitHub, you can find a different kind of projects where you can download to the SD card on the Raspberry Pi, where it'll take a lot of different faces from like Google Images, but then more specifically, you have to go off that and find the faces. So right now I'm having it detect my face because that'll be the easiest. Mm-hmm. But yes, it is something that you would have to train.
That's really cool. Could you hold it up again? And I'm going to make your screen full screen so people can see it.
Yes. And then the back is just that.
That is excellent. Well, thank you for sharing that. And like I've said to some other people, we'd love to see more about it in the future. If you want to send a video in or bring it on in action sometime on the live stream, or just talk about your progress with it, we'd love to hear more.
Yeah, I'd be honored. Thank you.
Thank you. Thanks so much. All right. Very cool stuff. Let's see. Next up, we've got Kevin, the other Kevin. Let me bring you on here. And hey, Kevin, how's it going?
Get my phone set up for this.
Right on. Yeah. So we're trying something tricky here. We're going to get a second camera.
Get 2 cameras on. Let's get this. Sorry for. There we go. Camera. Enter. Cool.
Right. Hey, I've done it.
So my project is I can hear my echo. That's not good. Let's move this. My project is a home-built CPU, you can see. This is a completely homemade CPU. So we have here the heart of everything, the CPU chips, and we have here all the memory and all the wire and circuitry, and I have an Arduino here to talk to it. And I'll just give you a really quick demo as to how this whole mess works. So first thing we need to do is to program the memory. And I've already done it over here. You could see it does some magic here. The program basically writes some bytes and magic instructions to the memory for the CPU to actually execute. Now, the second step would be to actually program the CPU. The CPU is made using something called an FPGA, which is, let's connect the board. An FPGA, which is a field programmable gate array. That means there's a lot of tiny little logic blocks that you could configure. So this is not an emulation, it's not a simulation, it's an actual real logic, like silicon emulated CPU. The third step would be to interface with the CPU somehow. Obviously, you could see you can't interface it through it with USB because USB is a very complicated protocol, and you can't interface with it through anything else but the Arduino. So I uploaded this to the Arduino, and we have to connect a wire. Let's get this wire in. You should see an LED light up, and this is very interesting. When you reset the CPU, you should see the LED blink. It actually blinks 7 times. So while it blinks 7 times, I'll explain why I'm doing this. Traditionally, the hobbyist market for like hobbyist projects, they include things like PCBs and they include things like chips and other stuff, but you never see a hobbyist design a chip from scratch. They always buy chips. And that's because the chip flow traditionally is very proprietary and closed source. And this project is part of a bigger project. It's called Homebrew Silicon Club. Give a shout out to those people. This was independent, but now I've kind of merged. Through there, we're trying to design open source chips, and this is the first step. Anyways, so it blinked 7 times, and after you could see there's a little output, and that 0 is the sign of life. That's the CPU outputting 0 to the computer to let it know, hey, I'm alive. And
Great.
Yeah, it's my project.
That is fantastic. And how long did you work on this? Was this something you started at the beginning of the summer?
This was, well, the idea came up 5 years ago for building my own CPU. And this summer, I experimented a bit, and I posted on something called the Scrapbook. And Sam actually said, hey, you know, we have this hardware thing going on. And I said, wow, I could actually build this and make it a reality. And here I am, 2 months later.
Really impressive work. I'm so glad it worked out that way. Fantastic, Kevin. Hope we see more of it sometime in the future. All right, take care.
Bye-bye.
Okay, let's see. Next up, we've got Jason. I'm going to bring you on. Hi, Jason.
Hey.
Nice to meet you. So what have you got to show us today?
So I've been working on this project that'll basically let you work on code locally from a device that usually doesn't let you run an IDE like an iPad. I don't personally have an iPad with me now, but basically the idea is I have a Pi Zero here. I don't know how well you can see that, but it shows like system status. It's showing the current date and time. And then it also shows like an IP address and an SSID for any device with Wi-Fi to connect to. And basically what I'm doing is I'm running something called Code Server that basically lets you, in the web browser, run an instance of VS Code, and you have like a terminal, a file explorer, and you can do basically whatever you want.
Wow. So this allows you to use any client as your programmer, like an iPad, like you said, onto another device.
Yeah.
That's really cool. And is this a project that you started at the beginning of this summer?
Yeah. It's just been taking a while with like designing the case and stuff. I'm actually like printing another prototype of the case right now, but yeah, this has been fun.
That's great. And it involves a lot of different skills. So you're designing and 3D printing, as well as, I imagine, coding for the Raspberry Pi to enable it to work as the sort of middle device.
Yeah.
Very cool. Well, thank you so much for bringing it on. And if you ever want to show it off to us sometime in the future, maybe with an iPad connected or whatever you have, we'd love to see it.
Awesome.
Thank you, Jason. Great work.
Thanks.
All right. Let's see. Next up, if Your camera is working. We'll bring on Artash and Arushi. Yeah, there's your camera. Hey, hello.
Hey,
Hi.
great to meet you.
Hi, nice to see you. So what project did you guys build this summer?
So our project is called the Math Scales. And there we go. So hi, by the way, I'm Artash. I'm in grade 9. I'm from Toronto.
Hi everyone, I'm Arushi and I'm in grade 6.
So the whole idea of our project came a few months ago after schools closed because of COVID-19. We realized that, we were at home, and when we woke up, we didn't hear as much cars at construction as we usually do. In fact, we could even hear birds chirping outside, which was really unusual. And we were curious about what other changes were happening in our environment during this COVID-19 lockdown. So would the sound be less outside? Since there was less cars, would there be less pollution?
So to solve this question, we made an instrument with sensors. It's right here actually. And so I put a pollution sensor, a sound sensor, and a light sensor, and I kept it outside my balcony to get live readings for 3 weeks.
And I was also curious about what the change in traffic would be on the road. So I set up a camera outside my house overlooking the main street, and I created an artificial intelligence-based program to count the number of cars on the road. So the way I did this is to take 2 pictures and subtract these 2 pictures to get all the moving objects. So then I would count these kind of blobs of moving objects to determine how many vehicles are in the road at a certain point.
So the results that we got for the pollution and the sound, they both decreased. And in addition, we took 2 external data sets, the NASA Nightlight data from the virus satellite and the COVID-19 cases from the Toronto Health website.
So in fact, like the pollution decreased by 40%, for example. And in terms of cars on the road, the number of cars at a given moment decreased by almost 2 times during the COVID-19 lockdown. So it definitely had a large impact on traffic on the street.
So, but this was not enough. We actually wanted to make our data into a musical so people can also hear it. So we decided to have a separate instrument for each data. For example, for marimba in G major, there was the passage of days and nights from the light sensor. Then vibraphone was for the vehicle emissions. Piano in E major was for the street noise. And flute was for the COVID-19 infection rates. In addition, for the tempo of the musical, we used the virus satellite data and the traffic count on the road.
So since our music was literally representing from during the COVID-19 lockdown to after the COVID-19 lockdown, each instrument represented a different change. So in fact, I can play you a short demo of this music.
Great. We want to hear it.
So in fact,
project. That is fantastic, guys. We need to cut you short because we have a couple more people that need to go and we're going to run out of time. But wow, amazing project. Thank you for sharing that with us.
Thanks.
Bye-bye, guys. All right, let's see. We've got Patrick up next and then Raynor-X. We'll try to fit you both in before we have to go. Hey, Patrick.
Hello. How are you?
I'm doing well, thank you. I'm really excited about the projects you guys have been showing. What did you bring to show us today from your summer of making?
This summer I made a smart album cover display. We're naming it Frame. And it takes the music that you're listening to either by recognizing in the room with an API or using the Spotify API. And then it puts it on a 16 by 16 display. And it's a piece of artwork. Really, it's really beautiful. I'd like to show it if I could share screen.
Oh, yeah.
And so here's a YouTube video that demos it. And so as you flip through albums, it swiftly and beautifully, updates the display. And it's really beautiful. And it's got a mobile app too, so you can configure it. And it's really exciting. Yeah.
That's gorgeous. I love it. Is this a display, sort of standard display you're using, or something you built to do the RGB pixels?
So it's an LED strip that we wired in snake formation, and so then I built a resample. We used a default resampling or resizing, but it wasn't good enough, right? So it didn't work for us. So I made my own, and then we flipped every second row, so that way this accounting for the snake out the snake method. Yeah.
Oh, that's terrific! Wow, you did such a nice job, and it's so fast. That one's really beautiful. Thank you for sharing that one. Love it. All right, and we got time for one more. Raynor-X, we're going to bring you on. Hello, Raynor. How's it going?
Hello. Can you hear me? Yeah.
Yes, I can hear.
Wait a minute, I'm screening. I'm sharing my screen.
Sure. I see a screen share. Here it is.
Yeah.
Is it not wanting to show the demo?
Okay.
You might be able to just scroll through it if it won't allow presentation.
Yeah. Yeah. Okay. Yeah, I think it's fine now. So this summer I was making a satellite imaging and weather forecast tower. It's quite a project about NOAA satellites. Many of you must be knowing about it. NOAA satellites, they are continuously emitting their data to radio frequency waves. And the project is about to receive their data and to make use of it for education and other purposes. So, okay, yeah. Let me show you some of my making. Yeah, here's the schematics of my project. So here's the NOAA satellite. Here you can see antenna and SDR, my laptop, and its data would be stored in Raspberry Pi, local servers, and for website. Let me share with you some of my progress. So this is, I'm still working on my antenna, and here are some of the photos of my project. You can have a look at my antenna. It's the SDR that I ordered from Adafruit, and is the extended version of antenna. I tried basically more than 2-3 designs of antenna to have a better reception. That's just all it is.
Very cool. So you're designing antennas to extend the range of the software-defined radio?
Yeah.
Very
to get satellite in it.
Well, thank you, Raynor-X. We appreciate it. Sorry, we need to cut you short, but before we go, I'm going to bring on our own Ladyada to say hi.
Hey, Hack Club members. It's me, Ladyada. With me is Mr. Ladyada Phil.
Hello.
I hope you all had a great summer with GitHub and making hardware and electronics and programming. Summer's a great time to do it. Well, mostly because we're all kind of stuck indoors anyways. Working on electronics and or coding and just being creative and fun and making something that can explore the world and sharing it with our friends. So thank you for coming by and sharing your projects. It was super cool. Don't forget to post your projects up on GitHub or post them on social media and share them.
Yeah.
One of the most important things.
Hack Club has a ton of places to put all the summer making projects, but don't let, just because the summer's over, keep publishing.
Yeah, post it up and publish. One of the things that I think a lot of makers and engineers do is they're like, well, it's not done and I don't feel like it's ready to share. But actually the best time to share things is at the beginning of a project because it's full of hope. Here's my dreams, here's what I want to do. And then, as the project continues, you might have setbacks, but then that's when people can come in and give you advice. We have a great Discord. You can come by. I think Hack Club might also share projects and help each other. That's how engineering gets done. Engineers don't work alone. They work in teams. And part of that is each person has their own skill sets. And by sharing it, nobody gets stuck. They all learn from each other. It's like super powerful and awesome. It's like if you're playing a role-playing game, you want to have a fighter, you want to have a mage, you want to have a healer, and you want to have like number four, usually like a ninja or like some black belt type thing, right? Like some hand-to-hand combat. So, you want to have a team that has all these different skills, and that's how you're going to win the game and defeat the dragon.
Yeah, and I wanted to say thanks to Sam and the entire team. I worked on some of the behind-the-scenes stuff with some of the Hack Club things. Great work, Sam, bringing all this together. And thanks for having Adafruit as part of it and as part of the hardware grant, getting as much hardware as we can out in the world. I think we all started this, and it was a different world. We'll all get through this onto the other side, and the versions of us and all the things we learn and all the people we meet virtually and in person matters quite a bit. So thank you, Sam, again for bringing everyone together. A lot of good connections were made.
Thanks everyone for showing your projects. Minds are blown. Really great stuff. Thank you.
Awesome.
All right, we're gonna sign off this Hack Club show and tell, and then
we have another one in 4 minutes. That's how fast things are moving.
We never stop. All right.
You can come by the next one if you want to. I won't stop you. See you again.
Thank you, JP, for hosting.
Hope you all had a great summer of hacking.